Field effect transistors of MES type have the metal semiconductor structure and are built using gallium arsenide. Gallium arsenide has the following advantages compared to germanium: higher mobility of electrons in weak electric fields, an energy band gap almost 1.5 times wider and providing for a high electrical resistivity of the underlying, very low capacity of parasitics between the electrodes of MESFET transistor. The circuit of an NOT component of MESFET transistors contains a passive transistor VT1 and an input active transistor VT2. The passive transistor VT1 is connected according to the two-terminal pair scheme. It serves as the source of the drain current. The value of the current practically doesn't change within a wide range of voltage changes between the drain and the source region. A similar inverter is connected to the output of a NOT component. In the static mode, it is represented by an analogous circuit comprised of a Schottky diode and resistance between the gate and the source connected in a series. The circuit of a two-input OR NOT component contains a normally open passive transistor VT1 and normally closed input transistors VT2 and VT3 in a parallel connection. When voltages corresponding to the level of the logical zero are applied to both inputs, transistors VT2 and VT3 are closed. The level of voltage at the output is high. If high level voltage is applied to one or both the inputs, the corresponding transistor is opened. The level at the output equals that of the logical zero. The circuit of a two-input OR NOT component with increased interference resistance contains input Schottky diodes VD1 and VD2 realizing the OR function and transistors VT1 and VT2 creating the inverter, as well as transistor VT3 used to displace the threshold level of transistor VT2. The increased interference resistance is achieved by making the circuit more complex, increasing the surface of the crystal, and using a negative power supply.